No, so the idea is that what we are doing for trying to enable quantum networking at large, not only what Vicente was talking about, the implications of the how things can live together, and the quantum and classical, and is what we're doing in that direction. Basically, first of all, is just a little bit of motivation. Nothing especially, or that should not be that new. Why operators are now taking some more strong interest on this is about analyzing new opportunities for network services, connecting or taking advantage of quantum technologies, trying to leverage our existing infrastructure. We have been spending piles of money in laying fiber, interconnecting, passing homes, etc. And this is something that is an opportunity for making a little bit more of money, and for sure address social demands on higher security, better computation capacities, etc. And well, to some extent, gain some competitive edge with respect to our competition. And well, some time ago we started, and you have heard about the virtualized networks, software networks, etc. Let's try to go in that way and help in the network transformation. As you can see here, this diagram is an experiment we made precisely with the team Vicente was leading by the moment more than 10 or 12 years ago. So we have started with this some time ago, even before I joined the company, so that's something that this belongs to prehistory, if you think about it. So what we are trying to build for this is about building a reference framework that can be useful for exploring quantum networking in all cases. For the short term, what is the most developed quantum communications application that is related to QKD and with quantum security. And in long term, thinking about the interconnection of different quantum computers or taking advantage of quantum interactions to improve networking. So the idea is that we are trying to make the technology evolve. Gemma was presenting this idea that we are at the very infancy. We are trying to accelerate growth, or at least to build this. You remember this Romanian, very famous Romanian girls and gymnastics that were 10 years old but able to do whatever. We're trying to go that way. So, and we're trying to follow the same principles and try to apply the same principles that have proven to be successful in, let's say, classical networking, like network concern separation, the use of fully open implementations, facilitating management and operations, and something that for us is extremely important is that things can be deployed and controlled in a seamless way. And for sure, this is about building something that for us is important as well, as having different providers, having the opportunity of going into a collaborative approach in which we can, at the very moment, try to build services and try to build infrastructures by combining and integrating open available solutions. For this is very much connected to what we are doing. From time to time, there are some discussions on whether we're going too fast in standardizing certain aspects. My belief is that if you standardize the right things and then you don't go into trying to standardize architectures or trying to standardize individual solutions and trying to standardize the implementation is something that helps well if you focus the standardization in interoperability and the integration of different solutions, and you are open always to providing reference implementations that can be used as an example to make things happen. With this said, our goal is not necessarily, is not a quantum network. It's something that is a little bit different. And that's something that has appeared once and here and there is about that a pure quantum whatever, a pure quantum computing facility or a pure quantum networking doesn't make that much sense. What we need is something that is a combination of quantum and non-quantum environment. For many reasons, and you have there, it's about, well, basically it's about cost, it's about accessibility by humans, the human users that we have, because we, if you have noticed, we are not quantum enabled, we are rather classical. And well, it's about the cost. I mean, it doesn't make any sense to build a completely separate parallel quantum infrastructure. And we believe that this is something that is going to be very, very, very similar to the same convergence mechanism that we have witnessed in the past when telecommunications technologies, about the mobile networking, the optical fiber, or if you like, even the metaverse, if it even comes in the future. And what is true is that we are facing very similar risks on the, well, something that we have suffered in the past in the networking industry, like, as I said, over-architecting when talking about standards and regulation that is, well, if it is premature, can be extremely disruptive of innovation. Vicente talked about the MAT-QCI, where we are trying to make some experiments. This is another view. He was showing you the nicest one. This is the flat Google Maps. The idea is that we are trying to build it on real use cases. We are trying to involve users from the beginning, users that are very much focused on particular features. And for sure, we started with QKD, but recently we have run some experiments as well with oblivious computing. That is a feature that is extremely interesting in terms of communication. It's about transparently using the cloud without disclosing the data you're using for making the calculations. And we are trying to make it as real as possible, or as close to real conditions as possible. Normally, as I said there, normally for the bad, because that makes things way more difficult than if you have an ideal situation where you have laid the fiber only for your quantum infrastructure. We are using facilities that are in production right now. We're trying to combine traffics, and we are trying to combine operations, and it's become the most challenging one. As I said, everything is on production facilities. There is a strong emphasis on sharing the infrastructure, because if you think about it, that is the key support of the economic case for any network. We are sharing infrastructure so we can sell individually to users that they are using a dedicated communications connection, but what they are using is a shared infrastructure. And well, we have a tight collaboration with academia, with the projects that are being run, and as you see there, the external rings are academic. And right now is the core of the Spanish branch of two projects that are very relevant here in Europe, that are EuroQCI, attempts to build a quantum communication infrastructure across the whole Europe, and QSMP, that is a partnership on safe quantum communications. Oh, it's on the other direction, and it's not moving. 1 second. Now, so this is, as I was saying, we have started looking at the QKD use cases. We are trying to move into the future and try to learn what we have learned within the requests from real users, and running on real infrastructure, and running it with real people. I mean, when I mean real people, is trying to avoid what Vicente was saying about the postdoc. We were trying to avoid to have postdoc and have normal guys trying to operate this. And trying to learn about the complexity, because what you have on the left-hand side is the ideal 3 planes that we are considering for management, for control, and for the optical plane. When you have at the right-hand side is how a node looks like once you connect all the different elements that make the optical connections, the management of those elements, and you integrate the different schemas for controlling the whole thing. And you integrate the management networks, the collection of statistics or whatever. And for this, what we're working is on we are proposing an architecture framework. This is being discussed currently in the IRTF. We are proposing a framework that should allow us to reason about the different proposals, because right now for quantum networking, there are many proposals on routing, on management, on the different layering of the different interactions. There are proposals about how to build or how to package data, or how to package the equivalent to data, whether we can talk about something similar to a packet or not, whether we can talk about something similar to an address or not, how do we establish all the necessary relationships. What you're talking is about the network, not about a point-to-point connection. And we are dividing, or we are proposing three strata, in which in each strata, one of them is very much focused on the quantum, purely quantum aspects, what happened and how the quantum interactions happen. And there we will be looking at how the, I don't know, entanglement swapping on things like that can happen. A service stratum where the focusing is what is the purpose of that connection. In the case of QKD, we're talking about synchronizing the keys to be used, but in other cases, we're talking about the sharing of a particular quantum state, or in some other cases, because we are considering other use cases, like, for example, distributed quantum or integrated quantum sensing, or this oblivious computing. The services are not exactly that clear right now. And something that is essential is precisely how you put in contact the classical and the quantum world, because at the end, you will need to manage the connectivity. How you connect point A to point B dynamically, because this is the important thing. We're talking about the network. Let me insist. We are not talking about a mesh of point-to-point links. And we are trying to do something, apart from that, apart from defining this, the other thing that we are trying to do is to define an environment in which we can experiment with quantum networking at scale. Currently, whatever the experiments that are reported, even the MAT QCI, they are, if you think about compare with a real network, they are totally toy networks. And we're trying to learn principles, etc., applying mechanisms of building synthetic environments on which we can run experiments at scale without, falling in the trap of the extremely expensive equipment that we have. Well, extremely expensive and extremely difficult to produce. It's not so easy to have. It's not that you can go to your normal vendor of networking equipment and you can say, well, I need 500 nodes, quantum repeaters, quantum whatever for the coming months. That's something that is complicated. And so what we are building is we are trying to facilitate the use of a synthetic environment in which we can combine real, emulated, simulated, whatever, so we can make experiments. And if somebody comes with a brilliant protocol for quantum routing, to have the ability to test it and to see how it would behave at scale. It's just the last one. When talking about the call to action, in particular, what I would like to insist is that we would like to move from this, the famous Schrödinger's cat, that is nothing more than something that is a conceptual experiment, to this marvelous situation that is, you can call it the quantum plates or the quantum dishes, in which you have them broken and unbroken at the same time. So, let's make the whole thing real. Thank you.
Well, thank you, Diego.